Hello students, today's topic is calorimetry. In this session, we will have following topics. First is introduction to calorimetry, heat, temperature, specific heat capacity, difference between heat and temperature. What does this word calorimetry mean? Calorimetry is the branch of physics that deals with the measurement of heat energy. It is one of the methods for determination of specific heat or latent heats of the substances. So, as we read that it is a measurement of quantity of heat, let's first understand the basic term heat. Each substance is made up of molecules. The molecules in the substance are in the state of motion and molecule exert a force of attraction on the other molecules. That means molecules of the substance consist of total internal energy, which is the addition of kinetic energy and potential energy. In short, heat energy is the addition of kinetic energy and potential energy. Here, this is a hot body and cold body. Hot body has more internal energy. The molecules in the hot body have higher kinetic energy, that is, molecules are moving with a high velocity. As a result, hot body has more internal energy as compared to the cold body. This cold body in contact with the hot body, cold body warms up and hot body cools down. The internal energy of cold body increases and that of hot body decreases. There is a flow of internal energy from hot body to the cold body. This is a heat energy. Take an example where a cup of hot coffee is placed in contact with the iced tea. The water molecules in a cup of hot coffee have a higher average kinetic energy than that of iced tea. That is, molecules in the hot coffee are moving with high velocity. Molecules in each object are constantly in motion and colliding with each other. Every time molecules collide, kinetic energy gets transferred. When a cup of hot coffee and iced tea are in contact, heat will get transferred through molecular collision from the hotter object to the cooler object. Heat is measured in joules and also in calorie. The relationship between the calorie and joule is 1 calorie is equal to 4.186 joules. Few minutes back we spoke about heat energy, which is addition of kinetic energy and potential energy. Now let's talk about temperature, which is a measure of the average kinetic energy of the atoms or molecules in the system. In other words, we can say that temperature is a quantity or it is a parameter which talks about the degree of hotness or coldness of the body. When cold body and hot body are placed in contact, and the heat energy flows from hot body to the cold. Here, the body which imparts energy is said to be at high temperature than the body which receives the heat. Thus, the temperature determines the direction of flow of heat. Here, temperature determines the direction of flow of heat. Let's say we are measuring the temperature of a water bath. In order to make sure the reading is accurate, we usually wait for the temperature reading to stay constant. In short, we wait here for thermometer and water bath to reach at the same temperature. At this point, there is no heat transfer further. Does that mean that when two objects, object A and B, when they are placed in contact with each other and they are at same temperature, they have equal amount of heat energy in between them? That means when we took example of hot water bath and a thermometer, when thermometer was showing exactly the same temperature as that of hot water, does that mean that they are having equal amount of heat energy in between them? The answer is no, because temperature is not the only one parameter which determines the quantity of heat energy absorbed by the body. There are other factors which are affecting the quantity of heat energy absorbed. Those are mass, temperature we have already discussed, and the third one is material of the body. These are the three factors which affects the quantity of heat absorbed by the body. Let's discuss each one of mass of the body. Here, to raise temperature of 1 kg of water by 1 degree centigrade, the quantity of heat absorbed is 1 kilocalorie. And here, to raise temperature of 2 kg of water by 1 degree centigrade, heat absorbed by 2 kilocalorie. That means here the mass is 1 kg and in this case mass is 2 kg. We are trying to raise temperature in both cases by 1 degree centigrade. However, heat absorbed in first case was 1 kilocalorie and heat absorbed in the second case was 2 kilocalorie. This shows that the amount of heat absorbed is directly proportional to the mass. Let's move to the second, increase in temperature. Here, the mass is of 1 kg of water in both cases. However, to raise the temperature by 1 degree centigrade, heat absorbed is 1 kilocalorie. And here, to raise the temperature by 2 degree centigrade, heat absorbed is 2 kilocalorie. This shows that the quantity of heat absorbed is directly proportional to rise in temperature. Factor, that is the material of the body. Here we have taken two substances, copper and water, of equal mass. It was observed that heat absorbed in case of water is 10 times more than that of copper. This shows that the amount of heat energy absorbed depends upon the substance of the object, which is expressed in terms of specific heat capacity, which is denoted by C. To summarize the factors affecting the quantity of heat absorbed, we can say heat absorbed is equal to specific capacity, mass, and the rise in temperature. Specific heat capacity is the amount of heat energy needed to raise the temperature of 1 gram of a substance by 1 degree. Why do different substances have different heat capacities? Each substance has different molecular structure and intermolecular interactions. Depending upon that, different substances can store different amount of heat. By definition, we learned that specific heat capacity is the amount of heat energy needed to raise the temperature of 1 gram of a substance by 1 degree. Now, suppose we have two substances, substance A and substance B, then 1 gram of substance A does not contain the same number of molecules in the substance B. So obviously, the heat capacity of substance A will be different than the substance B. Specific heat is is nothing but how much heat energy is required to raise the temperature of a substance. For example, water need water needs to absorb a lot of energy before its temperature changes. That means water has high specific heat capacity. On the other hand, sand needs less energy before it shows any temperature changes. That means it has low specific heat capacity. This shows the difference between the heat and temperature. Students, we have already discussed the basic difference between the heat and temperature, where we spoke that heat is the internal form of energy, that is, it is the addition of kinetic energy, and is the quantity or parameter which tells us about the hotness or coldness of the body. Heat is measured in joules and temperature is measured in Kelvin. The amount of heat contained in the body depends upon three parameters which we have already discussed: mass, temperature and substance. And temperature depends upon the average kinetic energy of the molecules. Heat is measured by the principle of calorimetry and temperature is measured by thermometer. I hope this session would help you. Thank you.